Hello, let's continue our Sudoku adventure with Fletcher's Cross by Wuschel. So we have normal 6x6 Sudoku rules. That means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have a diagonal in the grid, this blue diagonal. That works just like a row, column, or box, where we're placing the digits 1 to 6 exactly once each along this diagonal as well. Not the other one, just the marked one. And then we also have some cells in the grid that are surrounded by dotted lines. Those are cages. Specifically, they are killer cages, which means digits within the cage sum to the value in the top left. And also digits can't repeat in the cage. So Sudoku would allow us to put a 1 here and a 1 here, but the killer cage forbids that. We cannot repeat. And then all these digits would add to 12. So I could do like 1, 2, 3, 6, for example. It doesn't have to be in order. Something like that. Oh, I just put it in order again. Anyway. So that's killer cages. Additionally, we have these question marks in the grid. Cages with the question mark in them all have the same value, which we have to determine. So that's it. Those are the rules. Additionally, we do have a cosmetic question mark here. That's purely cosmetic to point out that the cages kind of form a question mark as well. But anyway, those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, I think the first thing I'm going to do is I'm going to color these because these are all the same digit. We don't know what it is, but we'll call that green. And that does allow us to place green here. We should be able to place the last green as well. Yeah, right there. So green is in a 3-cell 7 cage. Now, a 3-cell 7 cage, if you know anything about killer, 7 and 3 can only be accomplished with 1, 2, 4 if you can't repeat a digit. And if you want to think about that, 1, 2, 3 is the bare minimum you could put, which adds to 6. So we have to add 1 to that, and the only digit from 1, 2, 3 we can add 1 to without repeating a digit is the 3. So it ends up 1, 2, 4. So that puts 1, 2, 4 in every single one of these greens. That's in a 6 cage, so we can either do 1, 5, or a 2, 4 pair. Let's see, what else can we do here? I feel like this 12 might be key. So 1, 2, 3, 4 is 10, right? So we need to add 2 to that. So we could do 1, 2, 3, 6, or we could do 1, 2, 4, 5, but those are the options. Now 1, 2, 4, 5 is interesting to me because it makes a quad here. And that would leave 3, 6 here. So that's one option. Otherwise we're 1, 2, 3, 6. Now, I'm not bothering to fill these two just because I want to see how it affects this column first. 1, 2, 3, 6 is a little bit less restricted. So I'm wondering if 1, 2, 3, 1, 2, 4, 5 ends up being a problem. I'm not immediately seeing how, though. All right, we do have this diagonal as well. Let's not forget about that. I mean, I could color all of 1, 2, and 4, but I'm not sure how helpful that is. All right, let's think about the 8 cage then. So 8 is it can't be 1, 7 because there's no 7 in the puzzle. So it's either 2, 6 or 3, 5. That's it. So let's fill that out. 2, 6, 3, 5. I'm not seeing an immediate problem with either. Obviously 2, 6 make green not a 2, but that's not necessarily a problem. It feels like I need to color more, but I'm not sure what to color. Okay. Let's color this. Let's make this purple and let's make this blue. So we know blue is not green, obviously. Now, something to think about is, can this be blue? And the only way that would be true is if green-blue was a 2-4 pair. But I can't rule that out necessarily. Now we know this isn't purple. That does put a restriction on green-purple. Green-purple can't be a 2-4 pair. Which means that blue can't be 1, right? So let's think about this. If blue was 1, then green-purple would be a 2-4 pair. And now this would have to be 5, 1. That's one way to see it, which would repeat the 1. Or the way I saw that was this would have to be purple because that's how you add to 6 with green. And that would repeat purple in the column. So blue is not 1. One of these two is a 1. Now blue and green could add to the 6. We wanted it to. Obviously green's not in the 12 cage. Now, so let's think about that. Green's not in the 12 cage. That might be the key. Because the 12 cage has, remember I said it was either 1, 2, 3, 6 or 1, 2, 4, 5. It has a 1 and a 2 in it. So the only way that green is omitted from the 12 cage is if it's a 4. And then that means there's no 4 in the 12 cage, which means it has to be 1, 2, 3, 6. So there was an issue with 1, 2, 4, 5. I just wasn't thinking about it right. That does make blue and purple. So we don't actually need the colors anymore because we know their values. So 4 plus 2 is 6. That's not 2, which means that's not 6. We can clean up the 2 in this cage has to go here. The 1's in one of these two. This not 2, so that's not 6, making a 3, 5 pair. There we go. We're off to the races. This is 1, 6 pair. Okay, I was trying to see if that was resolved, but I don't think it is. There's something about this 1, 3, 6 that's interesting to me, but it does mean this can't be. Yeah, where does this go in this row? It goes over here. This is the other 1, 3, 6. Or you can sort of think about this cell sees all 3 of these, so it sees a 1, 3, 6 triple. It also sees 2 and 4, so it's a 5, which also makes that a 1, 3, 6. But these are the same digit. And that's been true the whole time. Let's see. So the 5 in here, 5 in this box goes here. This is a 3 or a 6. Is this diagonal coming into play? We know this diagonal needs a 5, which is going to end up down here somewhere. This triple is 3, 5, 6. I'm going to mark that out because that makes a 3, 5, 6 here. So this is the 2 for the box. We do need a 1 down here, and these 1s point down, so that's the 1. And then this is the other 3, 5, 6, I guess. I need a 1 on this diagonal, and it can't go here, and it can't go on these two. So the 1 in the diagonal goes there. That gives us the 5 and the 3. We get the 6 here, the 6 here, the 5. 1 looks like it's collapsing. 1, 3, 6. 1. This can't be the 3 because of the killer cage, right? So that's the 6. That's 5. All right, and here we need a 2 and a 3. Not resolved yet. I need a 1 and a 6 down here. That will resolve all of this. And then I need a 2 and a 5 down here. That's the 5, that's the 2. This is a 3, that's a 3, and we're done. All right, so really it was about how these clones were taken out of the 12 cage, so they couldn't be 1 or 2, leaving only 4. So I didn't need to mess around with the whole coloring of the 7 cage and seeing how that affects the 6. But it was fun anyway. Hope you learned something from that. It's kind of a neat technique. But yeah, hope you enjoyed this. And if you did, then why not leave a like, subscribe, and a kind comment below.